Okay, so let us discuss some applications of the chain rule. The first example is still a slightly simple one. We take capital F of x equal to e to the power 2x. Now we've seen several times that this is a composition of two functions, little f and g, where g of x is equal to 2x. So first we multiply x by 2 and then we put it into the power. So we do e to the power this argument. Fortunately, the derivatives of these functions are easily calculated. The derivative of g is equal to 2, and the derivative of little f is equal to little f itself, because it's e to the power x. The chain rule now immediately gives us the answer. What the derivative is, this is equal to first applying the derivative of g and then multiplying by the derivative of f, little f, evaluated at the point g of x. Now let us insert all these things. So the derivative of g is equal to 2, and we multiply it by the derivative of f applied to the function g of x, which is equal to 2x. And so we get, by replacing by inserting the expression for the derivative of our little f, we get e to the power 2x multiplied by a factor 2. Of course, after some experience, after some practicing, you will be able to do this much quicker. Okay, next example is e to the power, let us take cosine of x. Again, f is the composition of two functions, little f and g, where little f is the same as before, but g is slightly different. G of x is cosine of x. So we first take cosine of x and then we put it into the power cosine. What is the derivative of cosine of x is equal to minus sine of x? And again, the chain rule gives us, I do not have to rewrite it all the time, we have this expression. So we first insert the derivative of g, which is minus sine of x. I put it between brackets because of this minus sign, and then we insert our g into the derivative of little f, and then we plug in the expression for little f, which is e to the power cosine of x in this case. And of course we can now take the minus sign in front. So now let us look at a slightly more complicated example where we now have x multiplied by e to the power x to the power 3. Now what you see here is that we in fact have a product of two functions, where one is a simple one, it's just f1x is equal to x, and the second one is a composition of functions. Well, we will not worry about that. Immediately first we will think about how to compute the derivative of this product. Well, we had the product rule, and what the product rule said is that the derivative of capital F is equal to the derivative of f1 multiplied by f2 plus the derivative of plus f1 multiplied by the derivative of the second function f2. So we have to compute. Well, let us compute these things. The derivative of f1 is equal to 1. What about the derivative of f2? Well, f2 is a composition of two functions. Again, we always take powers of e. So we have our little f is always the same thing, but we have now we have a different g again, because gx is equal to x to the power 3. And little f is the same as before, so I will leave it, I will not copy it. What is the derivative of g? Well, we take the power in front, so it's 3, and we decrease the power of x by 1, so we get 3 minus 1 equals 2. Now, what is the derivative? F of f2 is the derivative of this g multiplied by the derivative of little f evaluated at the point g of x, which is equal to x to the power 3. And let us insert it. We get 3x squared, which is the derivative of g at point x, and we insert our expression for little f is e to the power x to the power 3. Okay, now we can combine all these things, and I will just copy it here. So what is this thing? Do I have enough space? So this is equal to f1 prime, which is 1, multiplied by f2, which is e to the power x to the power 3, plus f1 is equal to x, and f2 prime is this e to the power x to the power 3, multiplied by 3x squared. And so we can simplify a little bit. E to the power x to the power 3 plus 3x squared, 3x to the power 3 multiplied by e to the power x to the power 3. So this is the result. Okay, now I want to give a final example where we do a composition of more than two functions. Because of course we do not have to restrict to composing only two. And an example of this is just by computing not e to the power sine of x, but e to the power sine of x squared, for instance. And what you see is that you have a composition of three functions. The first one is just squaring x, then taking sine, and then putting it into the power of e. Now, of course, we can just first view it as a composition of two functions, f and g, where little f is again equal to our little f we had before, but now g of x is equal to sine of x squared. Okay, so we're left where we now have to determine the derivative of g of x. Well, g of x is a composition of two functions, say g2 and g1. So first we apply g1 and then g2, where g1 is equal to x squared, and g2, well, what do we do with x squared? We take sine. And we have the derivatives. The derivative of sine of x is equal to cosine of x. And so what do we get for the derivative of g? Well, it's the derivative of our g1, which is 2x, multiplied by the derivative of g2, which is cosine. And what do we take the cosine of? We take the cosine of our g1. Now I start to do it a little bit quicker, because you already saw this a number of times. Okay, now we have the derivative of g, and we can compute the derivative of capital F capital F, we have the expression here. So we now have to plug in the derivative of g, which is cosine x squared times 2x, multiplied by the derivative of our function little f, which is this one, e, and we evaluated what is the power here. It's the power is equal to g of x is sine of x squared. Okay, so sometimes when you get a little bit more practice, you will do it immediately, because what you do, you see this three-step composition. So first you compute the derivative of the first step is 2x, which is here. Then you compute the derivative of the second step is taking the derivative of sine of x is equal to cosine, but you plug in the argument we had here, so x squared, and then you take the derivative of e to power x, which is the function itself, and you plug in the argument you had before. So, but of course in this two-step decomposition this will be maybe simpler to do.